folks. Welcome to
Vector calculus.
Alright folks, welcome to the next lecture of vector calculus. And now, as you know, we're focusing on quadric surfaces, right? So these are almost like three-dimensional things you see in everyday life, like cylinders and cones. And in the last lecture, we found a kind of hourglass or nuclear power plant kind of shape. Alright, so let's see what kind of surface we get this time. So let's see what we have today. We got x squared over a squared plus y squared over b squared plus z squared over c squared all equals 1. So how does this thing look like? Well, first thing you gotta do is draw the xyz coordinate axes, right? So here's my z, here's my y. The hard part is always x, because you don't know if you're gonna mess up or not. And I have a feeling my x is not gonna be diagonal today. So let's see if we can. Oh, perfect x, okay. So here's my x-axis, here's my y, and here's my z. Picture perfect. Okay, so I got a 3D surface. I want to know how it looks like. Is it a cone, a cylinder, a ball, or a post-it note? Who knows? All we can do is find out by taking slices. As you know, the name of the game when it comes to 3D surfaces are slices. You gotta slice and you gotta see what are the slices. Alright, so let's first write down the equation. Rewrite the equation: x squared over a squared plus y squared over b squared plus z squared over c squared, and all of that equals 1. Now, how are we actually going to find how this shape looks like? Well, we can take some cross sections. Oh, don't talk loudly. Okay, so let's go ahead and take some cross sections. First thing I want to do is find how this thing looks like on the xy plane. So if I want to see how something looks like on the xy plane, I'm going to slice it on this xy plane. How do I do that? Well, I'm going to fix z to be 0. Alright, and I'm going to assume, by the way, that a, b, and c are all 1, just to make our conversation easier. Okay, so the xy plane is going to be fixed so that z is 0. So how's this thing gonna look like? Well, just set this term to 0, pop it out, and what are we left with? We're left with x squared plus y squared is 1. And what is that? Well, that's just a circle. If you look at the xy plane, you'll just find a circle, right? I think that's what you'll find. But one thing you should know is that, how about if we set z to a different constant? If we set z to a different constant like c, what's going to happen? Well, bring this over to the other side. If we bring this z term over to the other side, we're going to be left with 1 minus z squared. Now, what is that going to give us? Well, 1 minus z squared, does that remind you of anything? Well, hopefully, if you set z to a constant, this will just still be a constant, and you'll be left with some good stuff. Okay. Now let's look at our other cross sections. When you don't know what to do with one cross section, just look at your other ones. You got two other choices. Let's look at the xz plane. How do we look at that cross section? Remember, xz plane is this one. Well, to look at that cross section, I'm going to fix a different variable. Instead of fixing z, I'm going to fix y. Let's fix y to be 0. Take this term, pop it out. What do we have left? Well, we're going to have x squared plus z squared is equal to 1. Well, again, looks a lot like a circle to me, right? Looks a lot like a circle to me. So I'm going to have an xz like that. And finally, if I look at my yz plane, hey, what's my yz plane? Well, to figure out what my yz plane cross section looks like, I'm going to fix my x term. So fix it to be 0. Take this term, pop it out. We're left with y squared plus z squared equals 1. Now, you know what? I should have done this very nicely, because what we have here are 3 circles. All of our cross sections are circles. The xz cross section is a circle. The yz cross section is a circle. And, geez, I don't even know how to draw this anymore. But basically what we have is an M&M. an M&M shape. So what you have is a kind of circle in all directions. So you can imagine you have a circle this way, a circle that way, and finally you've got a circle kind of in between like that. And so you have a kind of crushed M&M shape. And we call this thing an ellipsoid. Ellipsoid. E-L-L-I-P-S-O-I-D. And that is the 3D quadric surface we just analyzed today, the ellipsoid. Alright folks, that's it for this lecture, and we'll check you out next time.
Ambition plus MKO plus scaffolding equals learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO, and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.